Hello and welcome to NHP's webinar on form of separation for switchgear assemblies. My name is Shane Townsend, Power Distribution Technology Specialist for NHP Electrical Engineering. This is just one in a series of webinars created to showcase NHP's smart devices powered by smart distribution and embedding smart safety into operational processes, providing our customers with better visibility into processes, data, and analytics. This webinar will cover the following topics: definitions and introduction to form of internal separation. We'll look at form ratings for internal separation to IEC and AS/NZS 61439. Also look at internal separation of assemblies using alternative means of constructions to AS/NZS 61439, Part 2, Appendix ZZ. We will look at some images of examples for each form throughout. What we hope you walk away with after this presentation is understanding the different forms of separation and why they are used, and understanding how the specified form of separation is likely to impact the assembly construction and its practicality. First up, we will look at what compels us to specify certain forms of separation for our assemblies and look broadly at some definitions. What is internal separation? The form of internal separation describes how we separate busbar, functional units, and terminals from one another to varying degrees. If you're not familiar with all these terms, don't worry, we will define them in the coming slides. Separation can be achieved through various means, such as rigid barriers, insulation, or the housing of devices. The two main standards that reference a form of separation for our assemblies are AS/NZS 61439 Part 2 and AS/NZS 3000. When considering a form of separation, the main goal is to reduce the likelihood of contact with live parts when the panel doors or external covers are removed, and reduce the likelihood of an arc fault occurring or propagating. We see here the reference text from the Technical Report 61439 Part 0. The main reason the switchgear assembly standard considers an internal separation or a form is when considering maintenance, upgrade, and extension to a switchboard where it is not feasible to fully isolate the supply. There are also strict legislation around performing such work without isolation and should be avoided unless justified using the guidelines in New South Wales Work Health Safety Act. Internal separation is listed in the 61439 standard as one of the many suitable precautions where it is not feasible to isolate supply to the enclosure. It is concerned with IPXXB protection against contact with hazardous parts and IP2X protection for the passage of foreign materials. It states that we can achieve this with barriers, insulation of live parts, and/or the housing of a device. The end user should consider their need for maintenance and upgrade and their ability to isolate the supply for the switchboard when considering a form of separation and higher degrees of protection. Keeping in mind it is rarely justifiable to work on a switchboard unless it is isolated from supply. As per AS 61439, any barriers must be a minimum of IP2X or IPXXB. This involves two requirements: protected against access of hazardous parts with a finger. The other requirement is protected against solid foreign objects of 12.5 mm in diameter and greater. When we are talking about form ratings, just think if the sections are meant to be separated, ask yourself, when you have access to one section, can you touch the other section with your finger? If yes, then it fails. AS 3000 also references forms of separation, specifically for boards rated 800 amps and over. AS3000 insists we take measures to protect against arcing faults while equipment is in service or undergoing maintenance for these heavy current switchboards. One of the methods listed to protect against arc faults is detailed in clause 2.5.5.2 and outlines a method of reducing the probability of initiation of a switchboard internal arcing fault. The method outlined to reduce the risk is to provide internal separation as per AS/NZS 61439 Part 2. In general, it explains we should consider how we separate busbar from functional units from one another, and terminals provided for external conductors from the busbar. There is also a note on safety services, which we will not focus on in this webinar. Similar to the technical report 61439 Part 0, it informs us we can use barriers, insulation, and housing of devices. It also lists which forms of separation are deemed to be acceptable to reduce arc fault initiation risk. In general, this is Form 3B, Form 4A, and Form 4B using all methods of construction. The different methods of construction are indicated with the additional I, and, or H, or the absence of these additional letters. It should be noted that a form rating does not imply internal arc fault testing. A form rating, along with safe work practices, are concerned with significantly reducing the risk of an arc fault occurring. AS3000 has extensive notes on this, which are paraphrased on the slide. For switchboards under 800 amps, AS3000 does not recommend a form rating, so this would be up to the end user, with all forms, or in most cases, no form of separation being acceptable to AS3000. After looking at why we would choose certain form ratings, it is important to broadly understand the components which we are needing to separate from one another. The first definition is our busbar. The busbar is any conductor that forms part of our distribution system within our switchboard. It could be copper busbar, insulated cable, or any other typical conductor. In general, any conductor from the load side of our incoming unit to the line side takeoffs of our load distributing devices would be considered part of the busbar when considering a form of separation and its construction. The next definition is terminals for external conductors. When considering the terminals in regards to a form of separation, we are describing how the cables or other external conductors that distribute load from or supply to our assembly will be connected inside the switchboard. Depending on the form of separation, it may be permissible to attach the external conductors directly to a device itself, like the terminal of a breaker, or there may be need to separate the terminal from the device, in which case we would need to extend the terminals as shown above. The third element defined for internal separation is the functional unit. AS/NZS 61439 defines it as part of an assembly comprising of all the electrical and mechanical elements, including switching devices that contribute to the fulfillment of the same function. In a typical main switchboard or distribution board, this would frequently refer to a circuit breaker per functional unit. If there is also metering, sensing, or other auxiliaries required for the circuit, they could be included in the one functional unit compartment, and these contribute to the function of that circuit. For a motor control center, a functional unit could include any number of parts, such as circuit protection device, contactor, overload, control wiring, relays, fuses, and anything else that contribute to the function of the one circuit. So essentially, the functional units are all of the functioning parts of our switchboard. Functional unit covers incoming and outgoing circuits. We will now take a practical look at the different forms of separation and how they will impact the assembly and how you interact with it. So where will we be looking for guidance for the form of separation and how this will influence the construction of our assembly? As defined in 61439, Section 3, a distribution board intended to be operated by ordinary persons would not have a defined form of separation. These type of boards have several restrictions, including a maximum incoming supply of 250 amps or less and no outgoing circuit greater than 125 amps. There are no forms of separation defined in Section 3 of the standard. It is, however, industry trend to specify a form of separation even when constructing to Section 3 of the standard. For these boards, it is generally more acceptable to use an alternate form of construction that we will cover in later slides. AS61439 Part 2 is for power switchgear and control gear assemblies. Most new switchboards and some panel boards are constructed to this standard. This is where we find the requirements for the different forms of internal separation. To 61439, all forms are acceptable. It is just another characteristic of the assembly that needs to be specified with respect to the application. It is typical in Australia for a board over 800 amps for Form 3B or ladder as per AS3000 to reduce the occurrences of arcing faults. Alternate forms of construction are also permissible, so be clear as to what you expect. Table 104 in 61439 lists the forms of separation as can be seen in the far right column. This is the name of the form and will describe how the elements we have defined will be separated from each other. The number alone specifies the main criteria as can be seen in the far left column. In general, the main criteria explains how functional units, bus bars, and terminals are separated from each other. By adding the letter A or B where applicable, we further define the required sub-criteria. The sub-criteria further defines how terminals for external conductors are separated, which is likely of greater concern to the contractor installing cables and the end user for maintenance. Table 104.101 from 61439 gives us the same information as the previous table. This table displays the information in a truth table format with a few explanatory notes rather than the descriptive style as seen before. The 61439 series also gives us a number of diagrammatic representations. The diagrams display our elements and the enclosure and barriers as per the above key. We have thin boxes to represent our enclosure and internal barriers, a bold line to represent our bus bar, a bold box to represent our functional units, and a bold circle to represent our terminals. We will use this diagrammatic format to look at some practical examples of the most common forms. We will first look at standard constructions which require rigid barriers for separation before then exploring alternate means of construction. Form 1. Form 1 is only required to have one external enclosure. There is no requirement to have any rigid barriers in our assembly to separate any of the elements from one another. This is the most basic form of construction. This construction would pose a significant arc fault risk for assemblies rated 800 amps or above, and we would need to consider other methods to mitigate the arc fault. Form 2A and Form 3A are rarely used in practice. By definition, they do not require separation of the terminals for external conductors from the distribution bus bar, so it would give little advantage from an arc fault mitigation standpoint. Form 2B is rarely specified for standard construction. We will address Form 2BI when discussing alternate means of construction. Form 3B. Form 3B appears as the industry norm for main switchboards and distribution boards over 800 amps. The general requirements. Busbar is in a separate compartment or otherwise protected with a rigid barrier. Functional units are required to be separated from the busbar, from other functional units, and also from the terminals for outgoing conductors. There is no requirement to separate the terminals for each circuit from one another, but they must be kept separate from the distribution busbar. The aforementioned typically translates to a board as per the right of the screen, with a separate compartment per functional unit, which extends to terminals for external conductors being placed in our cable zone. This form of construction allows for fast installation of external conductors on site, but has a slightly increased risk to the Form 4 construction, as all the terminals can be in the one compartment with no requirement for IP separation. To help visualize, the in-country notes for the AS version of 61439 also provide an alternate diagram of an example assembly. And here is another Form 3B construction with all the covers removed so we can clearly see the different sections and how they are separated. To the right, we can see another option for the terminals for our external conductors. The main difference between Form 3B and Form 4 constructions is the requirement to separate the terminals for external conductors for each circuit from one another. This would obviously enhance the safety. We would need to consider the impact on the installation time and the size of our construction. Form 4A and 4B will tell us where we place the terminals for external conductors. For Form A, we have all the same requirements as Form 3B, except now the terminals for external conductors are placed in the same compartment as our functional unit. This gives us separation of all our terminals and gives us a clear cable zone that will only be filled with insulated cables. This typically will not impact the size of the assembly too much. However, it does mean the installing contractor now has to make cable entries into each functional unit, which may slow installation on site. Shown for clarity here is the AS61439 example diagram, which clearly shows the terminals housed within the associated functional unit. Form 4B requires the highest degree of separation and is typically reserved for boards on the most critical sites. It has the same requirement as our Form 4A or 3B assembly, with the addition of the terminals requiring separation from the functional units and also from each other. This gives the highest level of safety and ease of installation. Visually speaking, this assembly would look like a Form 3B assembly, but now with a rigid barrier over each set of terminals. Above is shown the cubic terminal system with a perspex cover over the terminals to achieve this separation. This method of separating the terminals will add a little size to the board. There is sometimes the preference to have the terminals in a dedicated compartment, just like the functional unit itself, as opposed to in the cable zone with individual covers. This option could significantly impact on the size of the assembly. As means of comparison, we can now see the three forms in standard construction side by side. Form 3B with terminals open in a cable zone, Form 4A with the terminals housed with the functional unit, and Form 4B with terminals separated from the functional unit in the cable zone with individual IP2X covers. We will now move on to alternate means of construction, which move away from rigid barriers as the means of protection. AS 61439 Annex ZZ contains the in-country notes. These are essentially how Australian standard have modified the IEC standard. This also means that alternate means of constructions detailed within are unique to the Australian and New Zealand market. It explains that we can use the housing of a component when considering internal separation, such as separating one miniature circuit breaker from another miniature circuit breaker in a chassis board. If we are considering larger devices like motor case circuit breakers, which do not provide adequate ingress protection alone, removable covers are permissible to form part of the housing. It is dictated that when we use housing to provide separation as opposed to a rigid barrier, we must donate this with the letter H. For example, Form 4AH. Annex ZZ also tells us we can use insulation to provide internal separation. This could be insulating a busbar, insulated cable that contributes to our busbar system, or insulation of tables if we are separating them. It also covers the insulation of spare poles of a chassis with removable tee-off caps. When utilizing insulation to separate parts, we must add an I to our form to stipulate this, e.g. Form 3BI. Of course, we can use both insulation and housing at the same time and commonly do. A good example of this would be Form 4AIH. Annex ZZ also gives some detailed example drawings of the different forms when using alternate methods of construction. Its key details: functional unit housing, noted as B, bus bar protection, noted as C or D, and F for tee-off caps, bare or insulated internal conductors, as indicated by G or H, if any physical barriers are required, shown as I, location of terminals and whether terminals are IP2X or not, by J and K, covers for terminals on functional units, shown by L, and lastly, internal conductors indicated by M. With a good understanding of all the different parts, we will look at some of the more popular forms of separation using these alternate methods of construction and also discuss why some forms are not ideal. Like previously discussed, Form 2A and Form 3A are not preferred, and Form 1 requires no further separation. We will begin our examples with Form 2BI. Form 2BI requires that the bus bar be separated from the functional units and the terminals for outgoing conductors. It shows the terminals for external conductors connected to the integral terminal of the functional unit. There is no housing option, or 2BIH, as separation of functional units from each other is not required. While it is possible to offer Form 2B as per the above diagram on the right with an encapsulated chassis, 2BI will usually be nominated in case insulated cable or bus bar needs to be part of our distribution system, such as for metering requirements or to join multiple chassis together. This is a simple construction that requires attention to the IP2X requirement on the chassis or bus bar side of our functional units. In a Form 2BI assembly, this is achieved by insulated or encapsulated chassis with terminals of the functional unit maintaining IP2X on the chassis side of the functional unit. Miniature circuit breakers are inherently IP2X in their designs, so there is no requirement for additional covers. If multi-case circuit breakers are used with larger terminals, then terminal covers will be required on the line side of the breaker to maintain separation from the bus bar. There is no strict IP2X requirement for the load side of the functional units or terminals for outgoing conductors, but it is typically achieved in practice. Tee-off caps are required on the bus bar if no MCBs are fitted. The next common alternate form of construction is Form 4AIH. At first glance, this looks very similar to the previously discussed Form 2BI. In terms of the requirements, we are required to separate our distribution system from our functional units and our terminals for outgoing conductors. This is achieved in the same fashion as per Form 2BI. Furthermore, we now have to achieve separation between the functional units from other functional units and separate terminals for outgoing conductors from other terminals for outgoing conductors. This is achieved by the functional unit housing, hence the H in the Form 4AIH. The functional unit housing must maintain IP2X protection on the line side as before, and now additionally, the load side of the miniature circuit breaker or molded case circuit breaker must maintain IP2X protection, either by its design or the addition of terminal covers. The terminal covers must achieve IP2X rating or better to be acceptable. This means extra care is required by the installing contractor to maintain IP2X protection when making their terminations into the assembly on site. Practically speaking, when we are dealing with miniature circuit breakers, there will not be many apparent differences between a Form 2BI and a Form 4AIH assembly, as the miniature circuit breaker achieves IP2X. For more complicated designs, care must be taken to assure IP2X protection is maintained throughout the assembly, both during construction and also when installed on site. Form 2BI and Form 4AIH are the most popular forms of separation to be requested for small distribution boards and panel boards due to their enhancement in safety and relatively simple constructions. To conclude our discussion, we will talk about a few of the other alternate construction forms of separation that are no longer preferred. The first of which is Form 3BIH. Based on agreement between the assembly manufacturer and the end user, Form 4AIH will usually be offered in its place or a modified version of what is currently on the screen. As per the diagrams on the screen, Form 3BIH has the requirement as per Form 4AIH for busbar and functional units. It has the additional requirement of separate terminals for external conductors and does not expressly allow termination of outgoing cables to the functional unit. It should also be noted that there is not an IP2X requirement for these additional terminals. These terminals can complicate and add space to an otherwise simple design. This will usually be modified to allow the user to terminate onto the functional unit and omit the extra terminals and conductors. This, in fact, is changing the form rating to 4AIH if the IP2X is maintained at the terminal of the functional unit, or 2BI if IP2X is not maintained at the terminal. Form 4BIH is also shown in the alternate methods of construction. This has the requirement as per Form 4AIH for bus bars and functional units. Like Form 3BIH, it is required to supply a terminal separate from the functional unit for the outgoing cable connection. These terminals require physical separation via partition from the rest of the assembly. This again adds considerable size and complexity to the board. It can be achieved best by using a separate header box to which the assembly manufacturer can terminate to IP2X protected terminals for connection of the external conductors. As a final comparison, on the screen you will see the three of the more popular forms of construction, so we can see how standard construction versus alternate construction would impact the assembly. We have Form 3B for standard construction, which is typically larger and more expensive, but offers better safety and serviceability. We have Form 4AIH, which will typically be smaller and can be used for small sections or panel boards for molded case circuit breakers or miniature circuit breakers. It will typically be much cheaper, but we do have to consider potential heat rise issues as we're putting a number of circuit breakers in the one compartment, and there is the potential for one fault to affect adjacent circuits. Again, Form 4AIH or 2BI, which is typical for small panel boards and miniature circuit breakers. Again, potential for one fault to affect adjacent circuits. Looking back at what we have discussed, we looked at the different forms of separation available for switchgear assemblies. We also looked at some practical examples and how the different forms of separation can impact the final assembly. Thank you for joining us for this webinar. I hope you have found it beneficial, and if you'd like to watch it again or to find more webinars in this series, please go to nhp.com.au or our dedicated NHP YouTube channel. If you have further questions about forms of separation for switchgear assemblies, please contact your NHP sales representative. With smarter and faster decision-making and seamless connectivity spurring new collaboration, NHP is enabling the connected enterprise.